In topic 2 now of Unit 1, we'll take a look at operations in real numbers. Now, as a little review before we start, we can think of this. And my first question is, what does this refer to? So again, it's order of operations, and what we do first with the P is deal with grouping symbols, and a review of them would be parentheses, the most common, brackets, braces, the square root sign, the absolute value sign, and the division bar when we are having things that look like fractions. So for item number 1, and we're going to use the square, just write this statement. The sum of two positive numbers is what kind of number? And here the answer is going to be positive or negative. Well, it's going to be a positive number. And that would, in a sense, go there. Now, what would be an example of this? And some of these aren't meant to be difficult, just to illustrate the rule. Well, it would be letter A. All right, let's go on. All right, number 2, again, the statement. The product now, here we're indicating multiplication of two numbers with different signs. That would be, in a sense, one would be positive and one would be negative, results in what? And the answer is negative. And which would be an example of that? And if you said letter C, that is correct. Now in your notebook, you're going to write number 3. And it's this statement here. And here we have to get rid of our parentheses and do some calculation. So give it a moment and let's see what you get. All right, so we have a 7. Now the opposite of a negative makes this arrangement a positive. So this will become plus 8. The opposite of a negative makes this a positive. So this is going to be 4. So 8 and 4 is 12, plus 7, 19. So for example 4, you'll write this down, and this becomes, and I guess I left the answer there this time, a little hint. Well, the rule is in division as in multiplication, if you have unlike sign numbers, your answer is going to be negative, and 4 goes into 12 3 times. Now, as we look at number 5, take a moment to write it down. Now, there's a number of things going on here, And for instance, what would be the result of this here? Let's put another division bar, which is a grouping symbol also. So this is going to be a negative 28. Now, we have an exponent here, so we have to do what's there first. So this will be a negative 2. Now, what is being squared here? Negative 7 or just the 7? And the answer is just the 7. So when we square this, this becomes 49, but the negative sign still applies. So a negative 49. Now, when we square this 2 here, is it negative 2 being squared or just the 2? Same as what applies there. Just the 2. So this is going to be a negative 4 plus 4. Now, theoretically, you can complete this, but notice what's going to happen in our denominator. Our denominator is going to end up as a 0. Well, anything divided by 0 is undefined. So we would select B. This is not a real number. This is undefined. Anything divided by 0 is undefined. But let's do the top. So a negative times a negative on the top would give me a positive 98. And this would be a negative 28. And then we're going to subtract 28 from there, and we get 70 over 0 would be our final calculation, but we figured out having our denominator as 0, this was going to be undefined. All right. Now, the purpose of this review is to give you extra practice and acquaint you with vocabulary and protocol. And as we look at number 6 here, we're given the example, and write this down. 2 plus 5 equals 5 plus 2. And they're asking what arithmetic property is illustrated by this statement. Well, let's just review this because many times these get to be confusing or you just don't know the background. And I'd like you to write these words down here under this example as well. So the commutative property of addition is A plus B equals B plus A. So in addition, we can reverse the order and it's still a true statement. Now the commutative property of multiplication is AB, A times B, equals B times A. These are the same as well. Now the associative property of addition is, if you had 3 terms, we know this side equals this side. We're saying we could group with a parenthesis these 2 first, then add this, or we could group these 2 terms first and then add this. So associating terms within addition is legal. Again, this is the associative property, and this illustrates it. Now, the associative property of multiplication is that we know that A times B times C equals A times B times C. But we're saying you could multiply these 2 first, and then C, or multiply these 2 first, and then by A. So these are the symbolic references to these properties. Which one is illustrated here? Well, quite obvious, it would be A, the commutative property of addition. And again, you're going to be able to use your notes, and through the use of notes and study, hopefully goes from short-term memory into long-term memory, and then being able to use this knowledge to make decisions. Now, as we look at number 7, we're asked, in everyday things we do, sometimes things are commutative. That is, you can do one and you can do the other, or the other first and then that. And take a moment, look at these, and we can call these like A, B, and C. And we're going to ask you whether or not these activities would be considered commutative. That is, you can do one before the other without anything unusual. But in some cases, you couldn't. For instance, you can't put your shoes on first and then your socks. That would not be commutative. All right, give you a few moments. So it looks like I gave that first one away. All right. Now for this next one, again, getting dressed and taking a shower. You can't take a shower. You can take a shower first and get dressed, but you can't get dressed and take a shower. Get all wet. All right. And then this last one, eating cereal. Yeah, you can do that first. Drinking orange juice and then drinking orange juice and cereal. Yes. So something like this. And again, it illustrates that some of these rules in life apply to mathematics. Now, as we look at number 8, we're just asked to simplify this. Now, my question, are you squaring a -4 or just a 4? Again, your base here is described as the -4. So in this case, you're squaring a -4, and this differs from this. In this case, you're just squaring the 4, not the negative. So this will end up as a negative. This is going to end up as a positive 16. Now, for number 9, I'd ask you also to make a little diagram of what we've done here. Here is a mountaintop that has this height, and this is an oceanic trench that is this many feet below sea level. Now, you want to find what is this total distance. So you're going to take your first number and subtract it from the other to find the total distance. All right, see what you get. Now notice an interesting thing happens here. When we subtract a negative, the opposite of a negative makes this positive. So our answer is 38,723 feet. Now, if you think of it in terms of this total distance, you can see where you get down here to 0, and then you go some more distance, and you get to this bottom. So the total distance would be not just the difference of these two numbers, but keeping in mind this is negative. So in subtracting, it becomes positive. Now, in playing golf, I don't know if you realize that negative scores are sometimes better as you compare to par, but we're going to add these up, and what is the total score? Note you can do what I've done here, group all the negatives together, so this is going to be a -8, and then this will be a +2. So your end result then is going to be a -6. Okay, this wraps up our practice. You're going to be working on your own homework and of course taking our flipped classroom quiz.